Hello, so we're going to have a look at covalent bonding today. Now this is moving on from our ionic bonding that we've done previously. Please make sure all tabs on your computer are closed, your phone is switched off and put away, and you have a pen and paper ready to take notes and have a go at answering the questions. So we're going to have a look at what covalent bonding is and why it exists. So, non-metals form negative ions. An ionic bond cannot form between two non-metals because the charges on the ions are the same. They are both negative, so they will repel each other. Now, non-metal atoms instead form covalent bonds. Now, these are caused by atoms sharing a pair of electrons, so they each have a full outer shell. Now we can share more than one pair of electrons. A covalent bond results from the positive nucleus of each atom being attracted to the shared pair of negative electrons. This attraction is very strong. It's an electrostatic attraction, so it's very, very hard to break. Now, most covalent substances are simple molecules. They're made up of just a few atoms. For example, we've got carbon dioxide, CO2, water, H2O, methane, CH4, and oxygen, O2. Now, these substances are almost always liquids or gases. This is because the interactions between the molecules are not particularly strong. Therefore, they cannot stay in a solid shape. They're very, very likely to become liquids or gases. So we're going to have a look at how to draw covalent bonds, and we have a process that we can follow. We've got 6 steps. We're going to do some worked examples together. The first one we're going to do is hydrogen chloride. To start off, we write our H and our Cl representing our atoms, and we draw our outer shell around them, and we make sure that they overlap. Now, our first step, we need to choose one of the atoms from the molecule. I'm going to choose chlorine. We work out from the periodic table how many electrons that atom needs to gain to have a full outer shell. So for chlorine, it is in group 7. This means it already has 7 electrons. To have a full shell, we need to gain 1 more electron. We've done step 2. We're now going to draw this number of crosses in the overlap between the atoms. That is this bit we've got here. So I'm going to draw a cross in there. I only need 1 more electron, so I'm drawing 1 more cross. For every cross, draw a dot next to it. These are the electrons the atom is sharing in the bond. Finally, calculate how many electrons are in the outer shell but not involved in the bond. Draw these anywhere on the shell but not in the overlap. So I've drawn 1 electron that is involved in here. I had 7 in total. I've got 6 more to draw. So I'm going to add them on. I can now check that each atom has a full outer shell. So my chlorine will need 8 electrons. I have 1, 2, 3, 4, 5, 6, and 2 that are being shared. 1, 2. My hydrogen has 1, 2. You might remember that hydrogen on the periodic table will only have that first shell of electrons. There will only be 2 electrons. We can now say that this is done and we are happy with it. We're now going to look at another one. We're going to look at oxygen. So an oxygen molecule is O2. This means we have 2 oxygen atoms that will be sharing electrons. To start off, I'm going to draw this again. Now, our first step, choose one of the atoms in the molecule. They're both oxygen, so that doesn't matter which one we choose. So we look at oxygen on the periodic table. Oxygen is in group 6. That means it has 6 electrons in its outer shell. It needs to gain 2 electrons to have a full shell, that full shell of 8. I need to gain 2 electrons, so I'm going to draw this number of crosses in my overlap. Now for every cross, I'm going to draw a dot next to it. These are the electrons my atom is sharing in the bond. Finally, I need to calculate how many electrons are in the outer shell, but not involved in the bond. So I've drawn 2 crosses in here. I had a total of 6 to start off with. That leaves me 4 more to draw. I'm going to add them on. I've now added them on. I'm now going to check my electrons on my oxygen. I've got 1, 2, 3, 4 that aren't being shared, and 1, 2, 3, 4 that are being shared. That gives me a total of 8. If I check my next one, I've got 1, 2, 3, 4 that are being shared. I've not got any yet that aren't being shared. I need to add them on. I've got 4 more electrons to add on to make it into a full outer shell. I now have 1, 2, 3, 4, 5, 6, 7, 8. Both oxygen atoms have 8 electrons, but they are sharing 4 of them. Now this bit here, where we are sharing them, we can call this a double bond. This is because we are sharing 2 pairs of electrons. So we have 2 pairs of electrons. We're now going to have a look at one more. We'll have a look at water, which is H2O. That tells me I've got 1 oxygen and 2 hydrogen atoms joined together via covalent bonds because they're both non-metals. And a little tip for drawing these, find out which atom you've got the least of and put that in the middle. So we've got oxygen, we have the least oxygen, we've only got 1 oxygen, so I'm going to draw my oxygen in the middle, and I'm going to draw my hydrogens either side of it, and then draw my shells around it. And I need to choose one of the atoms in the molecule. I'm going to choose oxygen because I've only got 1 of those. I think it'll be slightly easier. Oxygen, we know, is in group 6, so it has 6 electrons. It needs to gain 2 electrons to have a full shell. And we're very lucky here. We have 2 spaces that we can add them in, so I'm going to add 1 in each. I'm going to draw a cross in each one, and then draw a dot next to it. That is my steps 3 and 4 done. Step 5, I need to calculate how many electrons are in the outer shell but not involved in the bond. So I've drawn 2 electrons. I had 6. That gives me 4 more left to draw. So I'm going to do 1, 2, 3, 4. I can now count up all of my electrons. So I've got 1, 2, 3, 4 not being shared, and 1, 2, 3, 4 that are being shared. Gives me a total of 8 electrons for my oxygen. My hydrogens, I've got 1, 2, and 1, 2, both of them being shared. That gives my hydrogens a full shell as well. So you're now ready to have a go at the questions. So key things to remember: a covalent bond is between non-metal atoms. They will share electrons, or share pairs of electrons. Each one wants to get a full shell. So we need a full shell. And that is either going to be 2, just for hydrogen though, or 8 electrons for all other non-metals. Follow the steps. You can rewind the video to look at them. Follow the steps at doing it and you will do fine. Any problems, do speak to your teachers and they will be able to help you. Have a great day and please do subscribe to the channel.